Picture this: astronomers have just unearthed proof of cosmic titans, black holes born from the ashes of previous stellar smash-ups, reinforcing Albert Einstein's revolutionary ideas on gravity for what feels like the umpteenth time. It's a discovery that's not just mind-bending, it challenges our deepest assumptions about how these enigmatic beasts evolve in the vastness of space. But here's where it gets controversial. Could these second-generation monsters hint at a universe where black holes are far more active and interconnected than we ever imagined? Dive in, and let's unpack this thrilling breakthrough together, step by step, so even if you're new to the world of astrophysics, you'll feel right at home. In a groundbreaking revelation, researchers have identified two remarkable pairs of black holes in the process of merging, with evidence suggesting that the heftier one in each duo is actually a seasoned survivor from an earlier collision. These aren't your run-of-the-mill black holes, they're what scientists call second-generation entities, forged in the fiery aftermath of prior gravitational tangos. The telltale signs of their unusual antics were captured through subtle disturbances in the fabric of spacetime itself. Yes, those are gravitational waves, the ripples Einstein predicted over a century ago as part of his theory of general relativity. This means, for beginners, imagine the universe's surface wrinkling like a pond after a pebble drops in, but these waves travel at the speed of light and carry clues about massive events billions of years away. The findings, detailed in a paper published on October 28 in the Astrophysical Journal Letters, offer compelling hints that these supermassive fighters emerged from what astrophysicists term hierarchical mergers. This process unfolds in crowded cosmic neighborhoods, such as bustling star clusters, where black holes keep bumping into each other with surprising frequency. These discoveries represent some of the most electrifying moments in our field to date, enthused Stephen Firehurst, a professor at Cardiff University in the UK and a key spokesperson for the LIGO scientific collaboration. They furnish tantalizing proof that these black holes stem directly from earlier mergers, he added in an official statement from the University of British Columbia. And this is the part most people miss: these weren't isolated incidents. The study draws from two recent detections of mergers that happened just 1 month apart, allowing scientists to decode the gravitational wave signals to pinpoint the black hole's sizes, spins, and distances from our planet. For context, gravitational waves are detected using ultrasensitive instruments like the Laser Interferometer Gravitational Wave Observatory, LIGO, which act like enormous microphones tuned to the universe's whispers. Since LIGO's historic first detection in 2015, hundreds of such mergers have been logged, but these two stand out for their peculiar traits. Take the first event, labeled GW241011, which unfolded on October 11, 2024. It involved a pair where one black hole weighed in at 6 solar masses, roughly 6 times the Sun's heft, and the other at a whopping 20 solar masses. They collided about 700 million light-years away. That's a distance light itself takes 700 million years to traverse, giving you a sense of the cosmic scale. What made this eye-popping was the larger black hole's blistering spin, one of the speediest rotations ever observed, nearing the theoretical maximum for such objects. This rapid twirl caused the black hole to warp under its own momentum, a phenomenon that aligned perfectly with Einstein's equations and the mathematical models developed by physicist Roy Kerr on rotating black holes. Then there's GW241110, detected on November 10, 2024, featuring black holes of 8 and 17 solar masses, smashing together 2.4 billion light-years from Earth. This one threw another curveball. The bigger black hole was spinning in the opposite direction to its orbital path, a twist that's unprecedented in the gravitational wave records. These mergers both featured a striking asymmetry. The larger black hole was nearly twice the mass of its partner, and odd spinning behaviors that set them apart from the typical hundreds of events spotted since LIGO's breakthrough in 2015. Scientists believe these unique characteristics point to the larger black holes having been sculpted in dense, high-traffic zones like globular clusters, where stars and their remnants jostle closely. This shines a light on the universe's hidden hotspots, those packed, dynamic regions where dead stars are forced into repeated encounters, explained Jess McIver, an astrophysicist at the University of British Columbia and a co-author of the study. For those just starting out, think of it like a cosmic mosh pit. In these clusters, gravitational pulls herd black holes together, sparking multiple fusions that birth ever more massive entities. Beyond the second-generation hypothesis, these observations lend further credence to Einstein's century-old predictions about the laws of physics. For instance, the clear signal from GW241011 revealed the larger black hole distorting as it whirled, its shape shifting due to extreme rotation, a direct match to Einstein's theories and Kerr's insights. Moreover, this event produced a distinctive hum in the gravitational waves, akin to the overtones in a musical instrument when one note dominates. This musical signature arose because the bigger black hole dwarfed its companion, and it too corroborated Einstein's models. It's like nature itself is composing a symphony that validates the genius of a long-dead visionary. Of course, this raises eyebrows and sparks debate. Is the idea of hierarchical mergers in star clusters the full story, or could there be alternative paths to creating these massive, oddly spinning black holes? Some theorists might argue that primordial black holes or even exotic physics beyond Einstein could play a role, but these detections lean heavily toward the merger scenario. And here's the controversial twist: if black holes are indeed building hierarchies in these dense environments, it implies a universe where such extreme events are more common than we thought, potentially rewriting our understanding of galaxy formation and evolution. Most people overlook how this could connect to broader mysteries, like the role of dark matter or the fate of stars in crowded clusters. What do you think? Does this make Einstein seem even more infallible, or do you wonder if these findings open the door to questioning his theories? Share your take in the comments. Are you excited about the prospect of more generation black holes, or does this complicate your view of cosmic origins? Let's discuss. This article draws from the expertise of Elizabeth Howell, who served as a staff reporter at Space.com from 2022 to 2024 and a frequent contributor to Leaf Science and Space.com from 2012 to 2022. Her adventures in space journalism include exclusive interviews with the White House, chats aboard the International Space Station, witnessing 5 human space launches across 2 continents, experiencing parabolic flights, suiting up in a spacesuit, and even simulating a Mars mission. Her latest book, Why Am I Taller?, co-authored with astronaut Dave Williams and published by ECW Press in 2022, explores the wonders of microgravity.